Back in the swinging 60s, when bell-bottoms were a hit and everyone was still mailing letters, some bright spark coined the term data science. Picture this: a bunch of folks realized they were sitting on a mountain of data but had no clue what to do with it. Imagine not knowing we'd be drowning in data faster than we can say cat video nowadays. Fast forward, and data science has morphed into this cool mix of computer wizardry and number crunching magic that helps us predict everything, from the next big stock to what color socks you are likely to buy next. Now, think of data science as the geeky backbone of everything from stargazing to saving lives, not to mention making a few extra bucks in the business world. It's like a Swiss Army knife of the tech world. Whether you are trying to spot distant galaxies or figure out how to sell more sneakers, data science is your go-to. In the beginning, it was all about stats and more stats. But then, like a plot twist in a sci-fi movie, along came artificial intelligence, machine learning, and something called the Internet of Things, which I'm pretty sure does not involve your toaster chatting with your fridge. Or does it? Suddenly, everyone realized they could track what you buy, when you buy it, and even guess what you'll want next. Cue the avalanche of data that businesses and pretty much everyone started hoarding like digital dragons. With the internet exploding and gadgets getting smarter, we hit the data jackpot. And once businesses figured out they could make a buck or two by mining this digital gold, everyone else wanted in. Now, whether you are trying to cure a disease, build bridges, or understand why cats go viral, data science is there, crunching the numbers and making sense of the chaos. Who knew numbers could be so much fun? A one-line definition of what a data scientist does is a difficult thing to write. The job has grown to encompass analysis of trends, plotting, informatics, machine learning, artificial intelligence, numerical analysis, word analysis, business analytics. Some of the earliest known use and utility of data science goes back to as early as first measuring the distance between the sun and the earth. Yes, even this has a use of data science. Today, this is a relatively simple task using radar or lasers. This was not the case when measurements were first starting to be made by Archimedes in the 3rd century BC. We continued to try to measure this distance in earnest, gaining a wide range of different results until Simon Newcomb came along in 1895. You guessed it. He applied data science techniques to get an incredibly accurate answer with quite limited resources. The main difference in Newcomb's approach was to use multiple data sets. He did not only use the really popular transit of Venus to get an answer, he also used aberration, the speed of light, and the Gaussian gravitational constant. Newcomb made sure the data sets he was working with were clean, and he collaborated with other scientists to ensure proper scientific rigor in his work. This all paid off with a highly accurate calculated value of 0.99940. It would take another 50 years for us to get closer to the correct answer. It's like humanity looked at a bunch of numbers one day and thought, "What's your story?" And boom. From scribbling tally marks on cave walls to teaching computers to predict what we're going to buy next, we've turned data into our crystal ball. It's kind of like how we went from inventing the wheel to landing on the moon, but with spreadsheets and algorithms. Now, diving into this world isn't just about digging up its past, it's like gearing up for a wild ride into the future. If you're dreaming of becoming a data science wizard in 2024, here is how you can do it. Step 1: concepts. In the foundational phase of your journey to become a data scientist, it's essential to establish a solid understanding of programming, mathematics, and statistics. Begin by learning Python and R, the two primary programming languages used in data science. Websites like Code Academy and Data Camp offer interactive courses where you can learn Python and R from scratch, covering topics such as variables, loops, functions, and data structures. Additionally, delve into fundamental mathematical concepts, including linear algebra, calculus, and probability theory, through resources like Khan Academy and Coursera. Understanding statistics is crucial for data analysis, so explore hypothesis testing, regression analysis, and probability distributions to gain insights into data variability and inference. Step 2, intermediate. As you progress, it's time to delve deeper into data manipulation and analysis techniques. Explore exploratory data analysis, which involves visualizing and summarizing datasets to uncover patterns and trends. Resources like Seaborn and Matplotlib documentation provide guidance on creating various charts, graphs, and plots to explore data effectively. Additionally, deepen your understanding of machine learning fundamentals by studying supervised and unsupervised learning algorithms such as linear regression, decision trees, and clustering. Andrew Ng's machine learning course on Coursera offers a comprehensive introduction to machine learning concepts and algorithms, accompanied by practical exercises and programming assignments. Mastering these techniques will enable you to build predictive models and extract valuable insights from data. Step 3, advanced. In the advanced phase of your journey, focus on mastering advanced machine learning algorithms and exploring big data technologies. Dive into topics such as ensemble methods, deep learning, and reinforcement learning to tackle complex data problems and improve model performance. Online resources like the Deep Learning Specialization on Coursera provide in-depth coverage of deep learning techniques using frameworks like TensorFlow and Keras. Additionally, learn about big data technologies such as Apache Spark and Hadoop, which are essential for processing and analyzing large-scale datasets efficiently. Apache Spark documentation and Hadoop tutorials offer comprehensive guides to getting started with these technologies, while online courses provide hands-on experience with real-world big data projects. Step 4, professional. In the final phase of your journey, focus on applying your skills to real-world projects and gaining practical experience through internships and collaborations. Work on projects that align with your interests and career goals, whether it's analyzing healthcare data to improve patient outcomes or developing predictive models for financial forecasting. Participate in hackathons and competitions to showcase your skills and networks with industry professionals. Additionally, stay updated with the latest advancements in data science by reading research papers, attending conferences, and joining online communities. Pursue relevant certifications such as the Certified Analytics Professional, or CAP, or Microsoft Certified Data Scientist Associate to validate your skills and expertise. Finally, develop soft skills such as communication, problem solving, and project management to excel in your career as a data scientist and make a meaningful impact in the field.